In this video, we are going to look at a probability rule called the complement rule. The complement of an event is the probability that the event does not happen. So in this picture, we have an illustration of what this event is. If we have the sample space, which is everything within this box, then we have the probability of the event A, which is everything inside this circle. And then the complement of A would be everything that is inside the sample space, but not within the circle of the event A. So it's everything else, all the other outcomes. So the probability of the event A and the probability of the complement of A have to sum to 1. So the complement probability formula says that the probability of A complement, and we use a little c above the A, kind of in like the exponent place to signify complement, is equal to 1 minus the probability of A. So let's look at a couple of examples of the complement formula. The first example says if there is a 25% probability of snow tomorrow, what is the probability that it does not snow? So 25% is the probability of snow. That is our event A. And then the probability that it does not snow is A complement. So we can find the probability of A complement, which is the probability that it does not snow, by taking 1 minus the probability that it does snow. Now, one of the first things we need to do whenever we see a probability given to us as a percentage is we need to convert that percentage into a decimal. We cannot do math with percentages. We can only do math with decimals. So while we can interpret probability as percentages, we cannot do any calculations with probability as percentages. So now I know the probability that it's going to snow tomorrow is 0.25. So 1 minus 0.25 is 0.75. And that is the probability that it does not snow. So I can say that there is a 75% probability that it does not snow. So that's one application of how we can use the complement. Taking a look at our second example here, the results of a probability experiment are below. Use the table and the complement rule to find the probability of randomly selecting a red Skittle. So here we can see a table where we have the different colors that come in a pack of regular Skittles and the probability of selecting each of those colors. And as we can see in this table, the probability of getting a red Skittle is unknown. But I do have all the probabilities for the other colors. And we know from our probability rules that the probabilities of all the events of an experiment oops, that's not how you spell experiment, have to sum to 1. So using that very important fact and the complement rule, I can find this missing probability by first finding out the sum of the probabilities that I know, and then using that to find the probability that I don't know. So I'm using the complement rule, but I'm kind of using it a little bit in reverse. So what I'm going to do first is I'm going to say, okay, what is the probability that I get a Skittle that is not red? So that's all the other colors. So that's 0.171 plus 0.216 plus 0.210 plus 0.223. Whoopsies. Those are all of the colors that are not red. So I'm going to add that up, and that gives me 0.82. And now I can use the complement rule to find the probability of selecting a red Skittle. And I can do that by taking 1 minus the probability that I get a Skittle that is not red, which I just found to be 0.82. So 1 minus 0.82 is 0.18. So this missing probability is 0.180. And I'm going to throw the 0 on the end just so that I'm consistent. All the other probabilities were reported to 3 decimals, so I'm going to give this one to 3 decimals as well. And that is another example of how we can use the complement to find an unknown probability.